Welcome, everybody. It is spotlight time. Now is the time when we have 10-minute presentations from members of our community about cool work that they are doing in realms that are relevant to the topic of our Impact Summit, air and water quality and related subjects. So our first guest is Vicarte, a Master's of Engineering student at Cornell University, here to tell us about FlowWat, a smart and sustainable way to analyze irrigation water flow. Take it away, Ellie.
So hi everyone, thank you for being here. My name is Vicarte. Thank you, Alex, for the introduction. As was mentioned, I'm a mechanical engineering master's student at Cornell University with a bachelor's of science in electrical and computer engineering and a minor in robotics. And today I'll be introducing you to my personal project, FlowWat, a smart and sustainable way to analyze irrigation water flow. So what is FlowWat? FlowWat is a water flow tracking system designed for monitoring irrigation systems. It is prototyped using recycled materials that uses a sustainable form of energy. It's a self-powering system that recycles the water flowing through irrigation pipes to recharge its own battery. This personal project was inspired from wanting to create a sustainable way to analyze flow rates in irrigation pipes for agriculturists without needing to worry about replacing external power sources. A reliable irrigation system that can consistently deliver water to crops, whether it be for farmers or agricultural researchers, is crucial for the well-being and health of the plants being grown. Having a proper working irrigation equipment monitoring system that can inform the user if there are any fluctuations in water pipe flow, indicating that there could be a leak somewhere along the pipe, can make a difference. Most of these systems right now are powered using rechargeable solar-powered batteries, but FlowWat introduces a different form of green energy utilizing hydropower. So why do we need it? Well, globally, farms account for 70% of all water that is consumed annually. Of that 70%, 40% is lost to the environment. And this is due to poor irrigation systems, evaporation, and poor water management. Additionally, irrigation data collection and statistics are not reliable. So from this website that I was researching on, the surveys found that statistics of irrigation districts are mainly based on information provided by either the water users, farmer associations, or even the companies that make the irrigation systems that they sell to farmers. These are all self-reported or collected through interviews in surveys and censuses. And the main reasons for the discrepancies in the data are lack of resources to frequently list irrigated land, even inconsistent data collection methods, which is where FlowWat comes into play, unknown whereabouts of small crops, even like illegal and unregulated water use, and even going as far as bureaucratic and political restrictions. So FlowWat can help to reduce these discrepancies and provide more reliable data for statistics. There are different types of irrigation methods. So the most popular is center pivot irrigation systems. Then there are drip and micro irrigation systems, flood furrow systems, spray sprinkler systems, sub-irrigation systems, and even surge flooding techniques, which is a very old technique to irrigate, but not very ecologically friendly. So FlowWat would target irrigation setups that require pipes to transport the water from a source to the sprinklers. And this includes center pivot irrigation systems, pictured above the very topmost picture, drip systems, the second picture on the slide, and sprinkler systems, which are pictured on the bottom of this slide. So how does it work? Sequentially, this is how FlowWat works. So on this diagram, we have the first step here. Water flows into the pipe from the irrigation source. Then the water goes through the hydroelectric generator, working like a water mill and generating power to the Adafruit featherboard, pictured below. So do note that currently the setup does not provide the full 500 milliamps needed to power the featherboard. It can only generate 83 milliamps with one generator, but as I will demonstrate in videos in the next slide, it can generate the full 5 volts. But then the water flow then goes into the water flow sensor, which is the third image on the third part of the diagram. And this takes data on water flow in milliliters per second. The water then flows out of the coffee filter that is attached to the end of this PVC pipe, so here number 4 on the diagram. And this was just a fun, environmentally friendly way to reuse a coffee filter into a sprinkler. So I'll now showcase some videos demonstrating the FlowWat. The first video shows the initial test run. You'll see that the hydroelectric generator is generating 1.7 volts. You'll see that in the video on a multimeter. And then I'll showcase live feed of the data uploading in real time to Adafruit.io. Also, if you notice that there's no audio in these videos, if you can't hear anything, don't worry, it's supposed to be like that. So in this first test, we actually used a pump to pump water from the bathtub into the pipe. And it'll pan into us in a second, but you'll see the multimeter, it'll read about 1.7 volts, and that's because the pressure from the water of this pipe is not as strong, so it's not generating as much voltage from the hydroelectric generator. And this is the live feed of the data that we're getting. Awesome. Now in the next video, we do another test outside, and this time we're connecting the FlowWat to our outdoor hose. This is our regular garden hose that we use to water the plants outside. And you can already see on the thumbnail here, you'll notice the multimeter is reading basically 5 volts, and this is due to the increased power output of the hose. And 5 volts is also the max output of the generator. So you see it's really turning in there. Now on to collecting the data. So once the data is collected we're using the Blues wireless cloud service, which is notehub.io. The data is then routed to the Adafruit.io cloud service, which displays the data neatly in a revolutions per second graph and a milliliters per second gauge. JSON Auto was used to format the data before sending the MQTT message to Adafruit. The top image in this slide showcases the data collected by the note card. So it has like the timestamps, and then you have like the data coming in afterwards. And the image below shows the data being routed to Adafruit.io to be displayed. And then on the bottom, you see the visual representation of the graph and the gauge that are displayed on the project page on Adafruit.io. So these are just some of the sources I use for this presentation. But onto future plans. So some additional changes that could be made to this project would be to improve the data collection consistency. We could also designing a more leak-proof pipe prototype, because if you notice in the videos, there was a lot of water still leaking through the creases. Maybe we could put some putty or something in there to prevent that. And test including maybe including a relay valve switch, so that when a big enough leak is discovered, there'll be a decrease in electrical current, and that valve would close that pipe, therefore saving you more on excess water leakage. And actually, Iraq, my dad, will be basing a new project off of this one with exciting new results, and with that will be a new Hackster project, and those results will also be presented at the Hackaday SuperCon in November. If you'd like to see more of what I've been up to in previous projects, or if you or someone you know is interested in hiring an entry-level engineer, cough, cough, please visit me on Hackster at Ellie Cyborg, LinkedIn at Ellie Vicarte, or my personal website at www.makerellie.weebly.com, or you can scan the on-screen QR code to take you directly to my site. But that's all for my presentation. Thank you for being here and listening to me. Thank you for supporting Hackster. I really appreciate it, and I hope you found this interesting. Thank you so much.
Oh, thank you, Ellie. Oh, that's a really wonderful, really nice way to tie it all together there. I'm very excited to check out your website, and I'm going to be at SuperCon, so I'm totally going to come see your talk.
Oh, awesome.
Yes. All right, so next up we have another guest who's going to be giving a presentation about her project. We have Sashrika Das, who is a 7th grade student at Eastline Middle Schools in Connecticut. Sashrika, if you'd like to join us now, we would love to see what you have to say.
All right, so thank you, Alex, for the introduction. So As you know, my name is Sashrika Das, and I'm going to be presenting a project that me and my dad have worked on, Smart Lake. So if you have any questions, please feel free to let me know in my Hackster. So I'm going to share my screen. All right. So lots of people do different activities in lakes. For example, they go kayaking, fishing, but not do just humans have all the fun. Even some dogs like to swim in the lakes. But there are some problems when you do different activities in lakes. Some problems that people may not even know that are there. This problem is called HAB, also known as harmful algae blooms. So blue-green algae release toxins in water that can kill animals and humans. An incident like this happened a couple months ago in our town, where a dog parent had took their dog to the lake for a swim, and the dog may have drank some of that lake water. And on the way back, the dog started panting and was taken to emergency immediately, but unfortunately couldn't survive. There's probably algae blooms in the lake. Me and my dad were shocked about this, and we were trying to figure out how we could be able to prevent those sorts of things from happening. So we thought, like, if we were to use different sensors, we could be able to combine all those different sensor data and create a model to predict the situation based on all those sensor data, like measuring temperature of water, the cloudiness of the water, and measuring the pH. So presenting Smart Lake, this is exactly what Smart Lake does. I even have the device with me. So basically, this device has a wheel terminal, the brain of the actual device, the temperature sensor, which checks the temperature, because whenever algae blooms, the optimum temperature has to be within 60 degrees and 80 degrees Fahrenheit. The pH sensor, because whenever algae blooms, the pH increases, so the water becomes more alkaline. The TDS sensor stands for total dissolved solids, so it will check like all the different chemicals in the water. The turbidity sensor, like I said in the previous slide, like it checks the cloudiness of the water, because algae mainly has like a cloudy effect to the water. And the reason we added the sunlight sensor is because, like, when you're checking the data for turbidity, it's possible that it could also be night. That's why like the chances are very high that like it's like very cloudy. So we have the sunlight sensor to reduce those false alarms. So like I said, based on all the sensor data, we are creating a model. So I'm creating the model from Edge Impulse using window size of 1000 milliseconds at same as window increase. I'm using classification keras and NN classifier. And I only have like, for this project, I didn't have much time to gather so much data, but generally I would need to collect data for like different seasons in different lakes at like different times, so we could get more variety of that data. So how the architecture works is like all the data, it's being sent to the Helium console, and it will show up there, and will show up in AWS IoT Core, and that data will be stored in DynamoDB, and that data in that live data will be stored in our dashboard that me and my dad created using React. So basically, in this project, along with that, me and my dad have created a dashboard which shows the live data from all the different sensors. And whenever like any algae is detected, like the health agencies can be able to integrate with the system to be able to see all that data, and they can take further actions. So some challenges that we faced. So like a problem was like a clash between the pH and turbidity sensors. For some reason, when we were like collecting the data, when you just had those two sensors in the water, like the data will change drastically between those two. Me and my dad are still researching on that, but we're still trying to figure that out. And the case designing. So, because like from every direction, the like sunlight sensor, it's always being blocked by like the case's shadow. So that we are trying to figure out. Then again, like this is a prototype, but like if we're turning this into an actual product, then we'll better change the design of this. And the data collection, as I said, like I didn't have much data, so it was very hard to like be able to make the right predictions for like the right timing. So thank you for joining me. And as I said, if you have any questions, please feel free to notify me in my Hackster. Thank you.
All right. Thank you so much, Sashrika. As Jessica pointed out in the chat, Sashrika is a winner of our IoT Into the Wild contest. $10,000 to bring this project to life and actually manufacture and deploy it with Seed Studios. So cool. So check out Sashrika's profile there for the prize-winning project. We're so proud of you and very excited to hear from you. And yeah, so our next presentation will be from, let me pull up my notes here. We've got Achim, who's from Air Gradient, joining us to talk about designing and producing a professional air quality open source monitor. He is passionate about air quality and balancing the commercial and open source sides of the company, something that has been a regular theme today. So welcome, Achim. Very excited for your presentation. Take it away.
So I want to bring you through a journey on how we ended up really developing a professional air quality open source monitor. And it all started in 2019, and that's basically what happened opposite my house. And I call it the night Air Gradient was born. So I was on a sabbatical from a pretty stressy job, and my kids went to a nearby school, and we lived in northern Thailand. And at this point, 2019 was really, really bad, like what you see in California. And the headmaster of the school was trying to make sense, like, is the classrooms air safe or not, was running around, and we were thinking like with another parent, like, hey, there should be an easier solution. So we started, building some air quality sensors, put them in a classroom, a small dashboard. And we also started to look at like, what's the underlying problem? So we organized a clean air camp with like local high schools, brought them on campus, brought them into the forest with firefighters. But we also started building very early on like sensors, what you can see on the right-hand side. And I think all of you know, putting something together with cables is not very sustainable. So very early on, we just made a very simple PCB, open source it, put it on the website. And then, like a few months later, a nursery from California came to us and said, yeah, we are building this. Can you help us a little bit? So we designed a 3D enclosure and put it on the website as well. And then basically after 9 months doing a lot of this work, like lots of workshops, I was kind of thinking, okay, should I stay or go back to my old workplace? And I became so passionate about the air quality like thing that I said, okay, let's stay. And we founded Air Gradient, but obviously also we need to, pay the bills. And so we were working on a commercial solution for like the data platform as well as the sensor hardware. And it took us actually 24 months to basically commercialize that kind of prototype that we put into the schools. And I think that's a big lesson learned often, and people, what they don't really see is if you have something working on a small scale, it takes probably 80% more to, so that's the 20%, it takes 80% to get really to the finish line. So there are things like, like really designing a professional enclosure took probably 6 months. We have to do mold flow analysis. In the end, you have to go through all the certifications often. Okay, where do I actually package this thing? Lots of specifications. And then in the end, how do I get this thing to the customer? How do I handle warranty and all these kind of things? So after that journey, end of last year, we were really like proud and happy to have our commercial monitor, Air Gradient 1, and went into the market, and we got one of the first projects from the UK, a very big government-funded research project where we put the monitors into 500 schools and collect data basically on classroom air so that they can think about improving ventilation rates and these kind of things. So working with the researchers there and the scientists made us really kind of think where we came from, you know? So because we started with schools, and then the first big commercial implementation was with schools, wondering what happened actually with this build instructions. So we looked on our website and we're kind of pretty amazed that like more than 60,000 people access these build instructions, that when you Google DIY air quality monitor, it's like, I think there are 4 or 5 of the top 10 hits. There was actually building a community forming around it, like the Home Assistant connection and other things. And then also like YouTubers like Jeff Gerling, for example, picked it up and talked about it. And we felt we actually want to put this on a higher level within the company. So we founded Open Air Gradient. And when you go on our website, you can actually see the Air Gradient 1 is our commercial offering. That Open Air Gradient is now basically on the same level, so it gets the same attention. And what we want to do is like, we want to increase air quality awareness by providing this open source air quality monitoring hardware. And then also like building a network with, you know, universities, NGOs to share the data like with the public. And then we were thinking, you know, it took us like 2 years to develop this commercial monitor. So what would happen if we try to transfer a lot of this knowledge and lessons learned basically back where we started into this like open source monitor kit, with the aim to potentially, you know, like create the best DIY air quality monitor out there. So what we did was then basically a bit of like a reverse engineering. So we looked at, for example, the plastic injection molded enclosure that was highly optimized here for plastic injection molding, and thought, okay, if you want to 3D print this and make it available as, you know, step file, STL files on our website, how can we simplify this, you know, like to avoid a lot of support material, for example, no? At the same time, keeping these like really good features that took us so long to develop it, like for example, this optimization for airflow so that we ensure like accurate measurements, also like that it's really easy to assemble. We did a lot of testing on different mounting options, cable management, and so on. So so this was like one of the first steps. And then we looked at the PCB, where we got a lot of experience during the design of the commercial monitor. Like, for example, where do we place components to ensure that the internal heat doesn't impact an accurate temperature reading? So you can see here, like, for example, the temperature sensors on the bottom left, and like the D1 Mini that we use for like as an MCU is on the opposite side, which creates heats, and then we put a lot of air gaps in between. So if you open our commercial monitor, you see actually a similar layout from the components. And this was another lesson that we could actually transfer. But then we went one step further and said, because this DIY or open source air quality monitor should be also very, very extensible. So we made a lot of like breakout points here. We also asked the community, like, what other sensors we would like to put in. So there was this Bosch BME sensor, for example. So we foresee this here. But what I like on the D1 Mini, even so the ESP8266 is getting a bit old now, is that they have these shields. So you could plug in like a battery charging shield here, for example, and then add a battery and have this basically running like off the grid. Then a lot of knowledge we gained on the commercial monitor was about sensors. So we transferred a lot of this, how to implement it, what's like the best code to access them, like things like checksums and so on, and actually created an Arduino library and put like all these sensors in. And we use the same sensor in the commercial monitor. So it's very, very accurate, and we can also source them from the factory very well. So what happened in the end? So on the left side, you can see our commercial offering, and on the right-hand side, you can see the open source version. And I think what people in the community really like is that you have this kind of nice enclosure, and it's basically very accurate readings from these experiences. My last slide here, just a few links. So if you can get a kit from us, we actually put a coupon code up there for the Hackster Summit, but you can also build it really without even we know that you build it. So you can just go on the instructions page, download the step file, the STL files for the enclosure, order your parts from, AliExpress or wherever you want, and then build the whole thing as well. Yeah, that's was my presentation. Let me see, are there any questions?
We unfortunately don't have time for questions right now, but I'm very excited to have check out those kits. Exciting to have a discount code as well. Thank you for joining us and telling us all about Eric Radiant. Oh, I just wrapped up this cafe with Chris Adams, and we were talking about all this technology for gathering air data and such. And so it's cool to, I hadn't even heard of this one. And now, I had from the speaker. Okay. Anyway, so our final spotlight is Bryan Costanich from Wilderness Labs, the makers of the Meadow Board, and he's going to tell us about impacting the Anthropocene. Now, this is actually Bryan from the past. We are sharing a recording of his talk, so even though he may seem to be in the present with us, he's actually speaking to us across time. So you will not be able to, he won't be able to respond to your questions if you put anything in the chat, but we will be happy to try and get those answered for you later. So take it away, Bryan from the past.
Hey, all right. Thanks for the introduction, and thanks for Hackster for hosting this and having us on. And thanks for those of you joining my lightning talk. I trust everyone is enjoying the Hackster Impact Summit. We've seen some really cool stuff over the last couple of days. And today I want to talk about the community of hackers here and why our work is so important and how we can leverage our skills to use industrial IoT to make sure that humanity continues to have a place on spaceship Earth. Because while industrial IoT may not be the sexiest part of IoT, it's a place where we can actually have a huge impact. Now, by way of introduction, my name is Bryan Costanich, and I am co-founder of Wilderness Labs. And we make a platform called Meadow that enables regular app developers to rapidly build secure production IoT with .NET and then maintain those devices in the field. And we have some pretty cool things to help you reach prototype in an afternoon or two, including this thing here. This is the Project Lab Board, which is a bunch of places to plug in peripherals from, Seed Studio, Adafruit, Microbus, etc. But today, what I want to talk about is something super important, and that is we are in the middle of a massive extinction event. In the richness of life all around us is collapsing. Even conservative estimates put the current extinction rate at 100 times higher than normal. Effectively, the planet is being sterilized, and this is actually the 6th major extinction on the planet. And by the way, the book of the same name by Elizabeth Kolbert is amazing, so I highly recommend. And the most important or the most interesting aspect about this extinction event is that while other extinction events happen because of large events like asteroids hitting the planet or massive volcanic eruptions because of tectonic plates or something, this one has a readily identifiable source as being us, humans. And in casual conversations, we attribute much of this to climate change, but in fact, climate change is a byproduct of our impact, and there's a much larger thing that's happening that we must understand in order to have an impact on climate change. So, first of all, a little bit of timeline context is helpful here. Sapiens, that is the current-ish version of thinking hominids, aka humans, are about 200,000 years old, and cities emerged only about 10,000 years ago. And of course, the Industrial Revolution got its start about 250 years ago. And the Industrial Revolution marked a massive change in the impact that humans made on the planet and marked the beginning of using machines for labor, right? Which really dramatically increased our ability to use resources. And since then, both population and carbon emissions have gone exponential, right? And because of this, the planet has undergone unprecedented change at the hands of humankind. So here's a picture of Dubai 50 years ago, and this is a picture of it today. And here's a picture of the rainforest in 1975, and just 40 years later, you can see most of it has been replaced by farms. And here's a picture of the once massive Aral Sea, and over 20, 30 years, it's been nearly completely drained for agriculture. And here's a picture looking at my hometown. This is downtown Seattle in 1880, and this is Seattle today. So from this, you can see that humans are having a massive impact. In fact, because we have been the cause of such massive planet-wide change, scientists have actually come up with a geological term to describe it. It's the Anthropocene, or the era of mankind. And this probably sounds familiar, since when we talk about climate change, we're actually talking about anthropogenic climate change. That is, mankind's effect on climate. Now, you're probably thinking, oi, Bryan, this talk is a real downer. But, look, there's still a lot of hope to be had, and our future is absolutely not written in stone. And just as we've had a tremendous impact in a negative way, we can also be a force for good. And the harder we fight now, the better things will be in the future. In fact, we're seeing a number of efforts already where we're turning the tide and making a positive impact. For example, this is a picture of the Gambela River Delta in Pakistan in 2013, and 4 years later, as part of the billion tree tsunami, it looks like this. And here's a picture. This is a NASA image of CO2 pollution in America on the northeastern part of America between 2005 and 2011. And you can see that there's massive reduction here. So massive change is possible. So I want to talk about how we do that. Well, probably the biggest challenge that we face in the Anthropocene is resource usage. See, resources on planet Earth are renewable, but not infinite. Using resources faster than they can renew causes a deficit spending. And if you map that onto a yearly calendar, the day by which we spend the planet's annual budget is called Overshoot Day. And it's happening earlier and earlier. So getting a balanced budget where life is sustainable means that we need to massively reduce our resource usage. So how do we do that? Well, we've got two options. The first is that we use less resources per human, and the second option is to have less humans on the planet. Now, less humans on the planet is outside of the scope of this talk, but there is some good news here, and that the population growth is already slowing down, and it's likely that it will hit negative growth in the next 50 years and potentially even sooner. So the other thing that we control is resource usage per human. Now, personal initiative here, such as recycling, reusing bags, etc., is super important. And it's important because every bit helps, but it's also a drop in the ocean compared to the impact that human industry has. So consider, as an example, water usage in California. California is the breadbasket of America, and 80% of California's water that doesn't drain off into rivers and such goes to agriculture. And it's the same for pollution. In the European Union, just a small number of industrial companies are responsible for over half of the pollution. So this means that even small increases in efficiency of resource usage in industry can have a major impact. So this is where we come in, because we have an opportunity to hack the IoT revolutions. the IoT revolution. In just a few years, there will be 10 times as many non-mobile connected devices on the planet as human beings. So while the last 15 years, in tech have really centered around the mobile revolution, the next 15 years will be centered around the IoT revolution, which brings us to the point of this talk. It turns out that industry also represents about 60% of the IoT market. So while IoT promises to offer an impact across the board, we're especially aligned to make a huge impact on our biggest source of negative influence on the planet. In a sense, this is the low-hanging fruit, and we can use positive business outcomes as a lever to make these transformations happen, right? And so a framework for thinking about this is measure, act, and outcome or result. And you can come at it from either end, but the point is IoT solutions really have 3 business or technology pieces. Measure a thing, act on that information, and to produce an outcome. And I want to explore a couple of scenarios where we're seeing this make an impact with our customers. So for example, one is industrial machinery. So for example, let's take a CNC machine that grinds away metal to make something, right? So if we look at measuring, first we want to identify the key metrics and what they mean. Okay, so let's monitor energy usage. And what does that mean? Is the motor pulling too much power? Is it time to replace it? Is there vibration and noise? Is the cutting head making chatter? Are we cutting too fast? What are the runtime hours? Is it time for a lubrication or scheduled maintenance? And then the act part of this is, okay, maybe we alert preventative maintenance notification to lubricate. Maybe we have to replace the motor because the motor's old and it's drawing too much power, right? Or maybe we need to slow the cutting head because it's going too fast and it's causing chatter. And the outcome here is less energy is used, so less resources are used and money is saved. Downtime is prevented, so money is saved again, and efficiency is increased, so money is earned. And then, of course, tuning this can mean a higher quality product, which means more customers, right? Here's another example. So logistics, let's talk about like shipping crates of bananas or something, right? So what do we want to measure? Okay, let's measure the temperature and humidity of the goods. Are the bananas, what does that mean? Are the bananas rotting? Are they in an environment where they're going to last this transport shipment? And then also maybe we want to measure or location using like GNS, right? The GPS. So we know where are these bananas? And what we can do there is we can act on this information. So maybe we can prioritize routing so that these bananas get to their endpoint before they rot. Or if and this happens all the time, containers are lost in port. Well, we can pinpoint their location with GPS, right? And a lot of the outcomes here are common to what we've seen in our other example. Money saved, money earned, more customers. And these are just, a couple of examples, but the revolution is just beginning. There's a huge opportunity to make an impact here because we're heading towards a place where we can put compute in nearly everything, everywhere. And that will give us unprecedented understanding and control of the world around us. Think about the difference in our lives before and after the mobile revolution, before and after Google Maps, right? And this will allow us to steer the Anthropocene not into a disaster, but into a renaissance of rich ecosystems and life on the planet. So, maybe we don't always immediately think of industrial IoT as being the most interesting place to make an impact. But in fact, I hope that I've inspired you to think about this actually as a place where it is a place where we can make massive positive changes. And we want to help you with this. So today we're announcing our own impact program where you can submit a simple proposal for something that moves the Anthropocene in the right direction and will help you with hardware sponsorship, help you with priority engineering support to getting you to prototype. And then once you get into prototype, moving that into production with our host of partners in the production world. So if you're interested in that, please go to wildern.es/impact and apply today. And of course, again, thanks for Hackster for having us, and thanks for everyone tuning in to my lightning talk. And I hope that you enjoy the rest of the day's festivities. Thank you. you.